Bismillah, alhamdulillah, salatu wassalam ala rasulillah. This is the first section in this course, MATH002. As you can see, this section is from chapter 2. We have finished chapter 2 and chapter 3. This section, in fact, we bought it in MATH002 because it is more related to chapter 4, more than chapter 2 and 3. It is about one-to-one functions and their inverses. After finishing this section, you will be able to identify what we mean by one-to-one function, what is the inverse of a function, how to find it, and how to sketch its graph. Let's start with the one-to-one function. You need to remember first, what is a function? What do we mean by a function? So when we have a function, what do we have? What is the function? Who can define? Yes, please. Good. The function, you can, there are many definitions for functions. So you can think about the function like a relationship or a corresponding between two quantities, such that let's give them names. Two quantities, x and y, as you said. And then for each x, one of them will depend on the another one. For each x, there is only one y. It will be connected to only one y. So if you think about it like you have two quantities, let's say y and x. So let's say that y depends on x. So y is a function of x. This is the notation that you usually do. Then for each x, there is only one. So if you have here a set, let's say that this is the domain of f. And this is the range. So f, what does f do? It takes x to y. So we will say that y equals f of x. In fact, here for each x here in the domain, there is only one value in the range. For each input, if you think about it like input and output, for each input there is only one output. Okay, this is a function. Now, there are many types of functions. There is a special type which we call one-to-one functions. Let me ask you this question. What about these two functions, f and g? Are they functions? These mappings, are they for functions? Is f a function here? This f, is it a function? Yes. How to know? For each element in A, there is only one element in B. Okay, it is connected to one element. Also, G is a function, right? For each element in the domain, there is only one element and it is corresponding to one element, not to more than one. For each input, there is only one output. This is what is special about functions. If you think about it like a machine. Now, I think, Shabab, it is clear from the name, one-to-one. So look at F. Is it one-to-one? Yes. Yes. The first one, it is in the domain. The second one is in the range. So is it one in the domain to one in the range? Yes. So this is the first one. F is one-to-one. What about G? No. Is it one-to-one or there is something not one-to-one? Look here. We have here what? We have 2-to-1. So we have two elements in the domain. We have two inputs with only one what? One output. So this is not one-to-one function. Great. So in fact, you will see later why we started talking about one-to-one before talking about the inverse of a function. Because we will see later that the inverse, in fact, we will do the opposite. We will think about a function that will take you back to the domain. It will cancel the effect of f. It will undo what f does. So f takes x to y, the inverse will take y back to x. So here in this case, we will not be able to do that because it will not be a function here. Because here, if you go back, if you use the inverse, the opposite process, you will have here one input with what? With two outputs. It will not be a function. So this is why if when we will talk later about the inverse, we should have one-to-one functions. So formally now, the one-to-one function, the formal definition is this. The function with domain A is called one-to-one if no two elements in the domain have the same image, have the same y value. In other words, the y values, y1 is not the same as y2 whenever the x values are not the same. I prefer to connect this to the definition of a function. If you remember, when you have y equals to f of x, we said that is a function if for each x value, there is a corresponding y value. Here we will do it from two directions. So a function is one-to-one if what? For each x value, there is a corresponding y values, and for each y value, there is x value corresponding to it. For each x, there is only one y, and for each y, there is only one. This is the one-to-one function. Okay. By the way, this is equivalent, you know, this is from the mathematical logic. This is equivalent to saying that what? If the y values are the same, the x values are what? Usually, this is what we use algebraically. If you want to show that a function is one-to-one algebraically, use this one. Use this relation. Start with f of x1 equals to f of x2 and show that x1 equals to x2. Is the function given by its graph, this function, is it one-to-one? I'm asking about this. Is it one-to-one? Why? Why it is not? So we have here two different x values. x1 is not the same as x2 because x2 is clearly greater than x1. But look at the value of the function at x1 and x2. They are the same. So here we have f at x1 equals to the value of x2, but x1 does not equal to x2. So two different inputs with the same output. In that case, we say that such function is not one-to-one. This function is not one-to-one. In fact, you can know that from the graph. If you have the graph, you can know that the function is one-to-one or not. Look here. Do you remember what is the test that had in MATH001 for functions? How to know that if you have an equation or if you have a graph, how to know that it is a graph of a function or not? By the vertical line test. Here we have a similar one, but we call it the horizontal line test because of course we use it here for the function, not for the inverse. So here, what is called the horizontal line test. What is it? This test says a function is one-to-one if and only if any horizontal line intersects its graph only one time. In other words, it is written here, a function is one-to-one if and only if no horizontal line intersected more than once. This means that if you have a graph, and there is a line intersected more than once, then it is not one-to-one. If it is not one-to-one, for sure you will find a horizontal line intersected more than once. This is the meaning of if and only if. And this is, by the way, the best way. I advise you to use it always. Whenever you can sketch the graph, this test, it will be the easier one to help you to decide. Like this, look at the cubing function, x to the power 3. What is the best way to show that it is one-to-one? Sketch the graph. Look, this is the graph of the function. It is well-known basic function. If you draw any line here or here or here, anywhere, it will intersect it only once. If you can find one row or one horizontal line that intersected more than once, then it is not. But algebraically also you can show it, ya shabab. Algebraically, how to show that this function algebraically is one-to-one? It is not difficult. What you will do, you will start with this. I don't prefer this way. I told you this is the best way algebraically to do that. You will assume that the y values are the same. You need to show that also x values are what? This is what you need to show at the end. So what is f at x1? It will be x1 to the power 3. What is x2? F at x2, it will be x2 to the power 3. What you will do, you will take the cubic root of both sides because you need to get x1 equals to x2 if you can. Of course, because it is odd radical, they will be cancelled, and you will get, of course, x1 equals to x2. So you show that it is one-to-one algebraically, but still geometrically is better and easier. What about the squaring function, x squared? Is it one-to-one?
No.
How to show? Notice, يا شباب, that if you want to prove that it is one-to-one, you need to prove for any x. So this is why we take the graph. The graph is about all x values. Or here we are talking about any x and 1 and x2. Now, if you want to disprove, what you need to do? One way is to sketch the graph, and if you sketch the graph, what will happen? This is the graph of y equal x squared. This is the graph of the function g of x equal x squared. Clearly, you can find infinitely many lines that intersect this graph more than once. It is enough to get one. If you can just find one line, then it is not one-to-one. Okay? Algebraically, how to show it? If you tried to do what we did here, some of you, they said, why we don't do what we did for x to the power 3. Let's try that. If you said that g, our function here is g, if you use g of x1 equals to g of x2, what will happen? You will get x1 to the power 2 equals to x2 to the power 2, right? Then you will take what? The square root of both sides. So we will get what? We will get the absolute value of x1 equals the absolute value of x2. And this means what? x1 is what? It might be x2 or negative x2. So this means that x1 equals to positive or negative x1. So it is not one-to-one. In fact, you don't need to do that in general for any function. If you want to disprove, just you need to find two x values that they have the same y value. Just look after two inputs with the same output. Yes?
We do have the graph.
This is what I'm talking about. If you don't have the graph, think about two x values and evaluate the function at them. If you get the same, then it is not one-to-one. Look here, for example, without the graph, we can show that it is not one-to-one. How? Take 1 and negative 1. Are they the same?
No.
But the value of the function at 1 is the same as the value of the function at negative 1. So here we have two x values different, but the corresponding y values are the same. So this will show that it is not one-to-one. We have here 2 for 1. Excellent. So what? We will just quit with x squared, and we will say that this function is not one-to-one. So according to that, it will not have inverse, because as we will see later, only one-to-one function, they have inverse function. In fact, if we take this part only, if you take this part only, it will be one-to-one, right?
Yes.
So this is why we do what is called restriction on the domain. We will restrict the domain. If we restrict the domain, it is still a function, by the way. It is a different function. This is for any x, for all the domain or the real numbers. This is only for the non-negative values. So this function h of x equals to x squared and x greater than or equals 0, it is one-to-one. Also, if you take another function, let's say k of x equals to x squared and x is less than what? 0. This function also is what? It is one-to-one. It is still one-to-one. Okay, so this is what is called restricted the domain. We restricted the domain here to make the function 1-to-1. Excellent. Now, in fact, we can generalize this idea. Whenever we have a function like this, when it is always, when it is continuous and increasing, or continuous and decreasing, it will be always what? One-to-one. So we have, I put it here for you, every continuous increasing, do you remember increasing and decreasing functions? Is always what? So every continuous monotonic function is 1 to 1. And this, of course, will lead us to this interesting fact. Is this function 1 to 1? It is. Just you want to show that it is 1 to 1. How to show that this function is 1 to 1?
You can use the sketch the graph.
Yes. It is easy to sketch the graph of this function because it is what? It is linear. So this is its graph. How many points you need to sketch the graph of a linear function? Just 2 points. You can find the x-intercept, the y-intercept, and that's it if you want. So clearly that this function is 1 to 1 because any horizontal line will intersect it only once. You can show it algebraically for people like algebra more than geometry. You can show it algebraically. How? You can start with the same idea. F of x1 equals to f of x2. Then for any x1 and x2 in general. Then this means that 3x1 plus 4 equals to 3x2 plus 4. And of course, you can subtract 4 from both sides. You will get 3x1 equals to 3x2. Then divide both sides by 3. You show that x1 also equals to x2. But of course, geometrically it's easier. Can we generalize now? Since this function is linear, so when you have a line like this or a line like this, whatever, its slope is positive or negative, it will be always 1 to 1. So can we say that every linear function is 1 to 1?
Yes.
Sure?
Yes.
This is, ya shabab, in math you have to be careful. So every non-horizontal linear function is 1 to 1. Now this is correct. So we have it here, by the way. Every linear function with a does not equals to 0 is what? Is 1 to 1. So when the slope is 0, we have what? We have horizontal line, and the horizontal line is not 1 to 1. Why? Because if it is, if what will happen if a is 0? If this a is 0, you will get what? You will get f of x equals to, what is this function? Constant function. Its graph is a horizontal line. Let's say, for example, f of x equals to what? 3. So this is y equals to 3. It is not 1 to 1. Why? By the horizontal line test. If you draw a horizontal line test, how many intersection points will be between it and between the graph? Infinitely many. In fact, if you want to give it a name, another name for the constant function, what is the another name for this function? It is horizontal function. Yes, the constant function, the graph is all to 1. It is all to 1, right? Whatever x is, y will be what? 3. So it is related to 1 to 1 function. This is all to 1 function. For all x, y will be b. So here, whatever x is, the value of b is constant. What about the vertical? What about the vertical? When you have a vertical line, is it 1 to 1?
Yes.
To be 1 to 1, it needs to be a function. Okay, you know that the vertical line cannot be graph of a function. By the vertical line test, it is not a function. It is not a function. We don't have 1 to 1 here function. This is the first recitation exercise in your recitation exercises. I'm sure that you can solve it. Please, in your notebook, try to solve this recitation exercise. If the graph of this absolute value function, x is less than or equal k, is 1 to 1, then a possible value of k is. You need here to look after a possible value. It is not only one value, maybe there are many. He's just asking for a possible value. Are you done with the attendance sheet? All of you? Okay. Thank you. Okay, guys. What you are doing? Let me see. Let me see. It is correct. It is enough. What you did is enough. Excellent. So if you want to give a hint for your colleagues, what will be your hint? Give them a hint.
Sketches.
Sketch the graph. Sketch the graph and you will know. So this is why, Shabab, you need just a hint and you can continue, of course. So thank you for your hint. Sketch the graph and you will know which x value can be instead of k. For those who want to check the answer is C, -1. How? It is not about MATH002, by the way. It is about 001, section 2.6. Do you know how to sketch such function like this? How? It is the same as the absolute value function. So you will start with the absolute value, and it will be shifted 1 unit to the left and 2 units. So here we have -1, -1, -2. So here we are. This is the vertex of this graph. If you want to draw it in an exact way, what you can do, when x is 0, you will find the y-intercept. It will be what? -1. So here we are. So we can, there is no reflection. It opens up, right? So something like this will be obtained at the end. Okay. Now, clearly it is not 1-to-1. Not 1-to-1. But if I choose specific value of x, it will be. So what we can, which part we can take to make it 1-to-1? So he said x less than or equal k. So what is the x value? Before it, it will be 1-to-1. If I take, for example, this point, is it okay? If my k is here, now x is less than, is it going to be 1-to-1? No. In fact, the point that you need to take is this one. This is the maximum number that you can take. So if you take just the part, if you take this function, you said that f of x, let's call it another function, whatever it is, y equals the absolute value of x plus 1 minus 2, and x is less than or equals -1. In that case, your graph will be this one. This is the branch that you will take only. This is 1-to-1. By the way, any value less than -1 also works. Right? If you take -2, for example, so if you take x less than -2, it will be also 1-to-1. So the maximum number here you have is -1. If you take 0, it will not be, because if you take x greater than 0, it will be something like this. It will be at from -2 here, from -1. If you take 0. By the way, what will be the answer if he said x greater than or equal 1? Sorry, greater than or equals k. If it is x greater than k, not less than. Also -1. Or any number greater than -1, but not less than. Right. Excellent. Now, as I told you from the beginning, why we are talking about 1-to-1 function, because there is something special about these kind of functions. Their inverse is a function. They have inverse function. To understand what we mean by the inverse, let's start understanding what is the function of a function. What is the job that the function do? What does f do? It takes x to what? To y. So this is why we said y is a function of x. Y depends on x. Now, if I have another function that undo what f does,
So to go from y to
it will be the opposite. It will do the opposite. It will be the inverse. So this is why the name is coming from. It do the opposite, the inverse of what this function do. Mathematically, they use this notation, f inverse. Don't read it f to the power -1. It is not f to the power -1. It is just notation like this. This is not a product. This is f of x. This is one notation. Also, this is one notation. In fact, it has some properties. There is a reason for that. But first of all, you should know that it is not a power here to the power -1. So the function that will do the opposite or the inverse, we call it the inverse, and we denote it by this. What does it do? It takes y back to what? To x. Okay. So in fact, if f takes x to y, we denote it by this. Y equals f of x. Now, when f inverse takes y back to x, we denote it also by this. So just look at this. These two relations, they are equivalent. When we say y equals f of x, it is equivalent to x equals f inverse of y, provided that this function is 1 to 1. What do you think here, Shabab? What is A here? A is the domain of what? The domain of what? And B? What about f inverse? What is the domain of f inverse? It is B. So in fact, we have here this interesting fact that the domain of the inverse is the range of the function, and the range of the function, the inverse, is the domain of the original function. Now let's come to the formal definition of the inverse. Let f be 1-to-1 function. If it is not 1-to-1, the inverse is not a function. So if you have a 1-to-1 function with domain A and range B, then the inverse function f inverse has domain B and range A, and it is defined by this. This is the most important equivalent relation that you need to focus on. When we say y equals f of x, it is equivalent to f inverse of y equals x. When we also say that y equals f inverse of x, this is equivalent to what? This equivalent to x equals f of y, and so on. Okay, what else? So shortly, ya Shabab, I will use this notation. I wish that it's okay for you. Domain of f inverse equals range of f. Just shortly like this. And range of f inverse equals to the domain of f. You are ready, believe it or not, to solve all the exam questions starting from the first class. You can solve this, please. You have a function here that is given for you, and it's still your lovely function, the absolute value. Then what is the domain of the inverse function? Think about it. Yes. D. Why they give you 5 minutes in the exams for such questions? You solve it like in 5 seconds. Yes. C. Good. We have 2 options so far, D and C. Yes. D. So forget about D, C, B, E. How? Give us a hint, please. Yes.
After sketch the graph, we rotate to the maximum value, and that will be the range of the f of x.
No, very long hint. I need a shorter hint, ya Abdulaziz. Who can give us a short hint? Yes. The domain of the inverse is the range. So the hint here is just find the range of the function. It will be the domain of the inverse. Now we will come to the details, ya Abdulaziz. How to find the range? You can find it algebraically or what? Or geometrically. Okay. What do you want to do? How to find the range? If you want to find it algebraically, it is easy. How to do it algebraically, ya Shabab? You will start with this fact. What is the domain? X is greater than or equal to 3, right? So the absolute value of x minus 3, any absolute value, will be greater than or equal what? Right? Now it is multiplied by what? By negative. So it will be negative less than or equal 0. When we multiply by a negative number, it will be changed. Then there is 2 added here. So we will add what? 2 for both sides. What is this? This is our y. So y is less than or equal what? 2. So this means that it is from negative infinity up to 2. This is the range of this function. And the answer is D. This is algebraically. Geometrically, of course, I heard someone said sketch the graph. So you can sketch the graph, and it is so easy. This is the same as the absolute value, but shifted 3 units to
The right.
you are right, to the right. Here's this is 3. Then it is what? Shifted down,
No,
reflected down first, reflected in the x-axis or the y-axis?
X-axis.
In the x-axis. So it will be reflected and then shifted what? Up 2 units. Here we are. It will be something like when x is 0, you have -1. When x is 0, it is -1, something like here. Let's say roughly like this. Now, what we are interested on is what?
The condition.
The y, the range. What is the range of this function? From -infinity to 2. These are the y values corresponding. Yes. It is not 1-to-1 because we didn't consider the condition. Yes, thank you. Here to sketch the graph, you should consider the condition. What is it? F of x equals to negative the absolute value of x minus 3 plus 2 and x greater than or equals what? 3. So this part is not included. So this is the graph of our function. And how to find the range? Just you need to go on the y-axis and look right and left. Wherever you can find the graph, this is the range. So the range here of the function is from -infinity to 2. And it is the same as the domain of what? Of the inverse. So the domain of the inverse is the range of the function. You are ready for measure 1, mashallah. Good. So again, I mentioned this, ya shabab. This is just a matter of notation. If inverse of x is not the reciprocal, don't mix up between them. We use this notation, if you remember, u to the power -1, it is 1 over u, but not here. When we talk about a function, inverse of a function, if inverse is not. In fact, if you want to represent this, no need, but if you, it is like this, f of x all to the power. So look at the difference between this and this, okay? It does not mean the reciprocal, be careful. What else now? How to find the values of the inverse, if you know the values of the function. What is, you have here f at 1 is 5, at 3 is 7, at 8 is -10. Now the question is, what is f inverse at 5? Why? You are right. Why f inverse of 5 is 1? How to justify your answer? Because, remember the definition, ya shabab. F inverse of y equals to x, f and only f what? Y equals f of the definition of the inverse. You need to understand this very well. So f inverse of 5 is 1 because f at 1 is what? F at 1 is 5. Now f inverse at 7 is because f at 3 is 7. And similarly, f inverse at -10 is 8 because f at 8 is -10. You can represent them using these mappings. From the table also, you can obtain the same. If this table is for x and h of x, what will be h inverse of 8? 3. Of 12? Of 3?
6.
What is h of 3? H of 3? 8. This is 3, this is f of 3. Excellent. Also from the graph, you can also find, if you have the graph of the function, you can find the values of the inverse. Who can tell me here, what is f inverse at 5?
7.
What you will do, you will look for 5 here? No, you will look at it here. So it will be at 5, what is the x value that is corresponding to 5? It is 7. Now, what is f inverse of 3?
4.
It is 4. Excellent. What is f at 6? 4. Is that right? This is 6. So f inverse at 4 is 6 and f at 6 is 4. Excellent. Now, the most important property for the function and its inverse is the composition of them. Do you remember the composition of two functions? f composed with g. What is f composed with g of x? It is f of g, right? Now, if you have two functions, and I think also you remember that the composition is not commutative. Okay, is that right? But here, in the case of the two functions, if they are inverses of each other, then the composition of them will be the same, and it is equals to x. So they will cancel each other if they are inverses of each other. So if you have two functions, the composition of them is x, then they are inverses of each other. Here, let me write it here this way. F inverse, I think it will be better for you to understand it this way, that you have here x, f inverse composed with f. And here f composed with f inverse. From the left or from the right, they should be the same, and both of them should be equals to x. This is only for inverses functions, if they are inverse of each other. Notice here that this x is not the same as this x. This x is where it is? In the domain of what? Here it is. This is x. It is in the domain of f. This is the domain of f. And this x, it is where? In the domain of the inverse. Here it is, by the way, in the range of the inverse. So it is the output. Here it is in the range of the function. You can think about it like the domain of the inverse, which is the range of the function. By the way, any two functions satisfy this, they are inverses of each other. This is the main criteria, Shabab, for you to check if two functions are inverses or not. Just find the composition of them. If they cancel each other, it looks like cancellation. This is why some textbook, they call this function cancellation property. Why? Because you have f inverse of f of x. In that case, they will cancel each other, and you will left up with what? With x only. It is kind of cancellation because they will cancel the effect. This is what I told you. When you have x to the power, here it is. Here it is. Why we talk about it? Here it is. When you have x to the power 3, how to cancel the cube? You will take the cubic root. So look at these two functions. How to show that they are inverses of each other? You will find the composition of them. So you will find g of f. Look, what is it? You will put f of x, it is x to the power 3. You will go to g, replace x by x to the power 3. It will be x to the power 3. You will get x. You should do it also from the right and from the left, because you know that the composition is not commutative, but here it must be. And it must be equals to what? 2x. I think you can solve this old exam question also by using the inverse function property and by the definition of the inverse. Please try to solve this old exam question. He gave you the function. He gave you a condition here, x less than 0 to be 1 to 1. Without this condition is not 1 to 1. Then he wants the composition of f inverse and f at -1 plus f inverse at 6. There is a trivial part here. Who has an answer? Yes. You mean B?
B, yes.
MashaAllah. We will see. Yes. 3, which is A. So we have A and B. Are you magician, ya shabab, or mathematician? How can you do that quick? MashaAllah. Yes. D. What about the other people? I told you that here you need to do or to find two quantities. This is the first quantity, and this is the second one. Which one of them is trivial? Which one of them is so easy?
The first one.
The first one. Why? Just you will use this property that you know that f inverse of f is just x. They will cancel each other. So this one is just what?
-1.
-1. Just you need to check, is -1 in the domain? Is this in the domain of f?
Yes.
This is the domain of f, x less than 0. So it is less than 0. You can find the value of the function at -1. This is so important. Now, so this is -1. Just you need to find this. The question is how to find this. Now we need to find f inverse at 6. The question is, what is this? How to do that? Yes. We don't know what is it. We don't know what is f inverse at 6. So is it okay if I just call it x? Something that we don't know what is it, we will look after it. Okay. Now, by using the definition of the inverse, what is this? You remember the definition of the inverse? F inverse of y equals to x. This is equivalent to what? Y equals f of x. So this is equivalent to what, ya shabab? F of x equals to, right? So this is the same by using the definition of the inverse. Now you will go here, replace f of x by what? By 6. So 6 here, which is x value, in fact, here it is y value in the function. What is x in the inverse? It is y in the function, and vice versa. So we have 6 equals to x squared plus 2, which means that x squared equals to what? 4, which means that x equals what? Positive or negative? How to decide? Don't forget this condition. They didn't give you this condition for fun. So you don't forget it, ya shabab. Here, from this step right here, x is less than 0. Here, x is less than 0. Here, in fact, if you take the square root of both sides, what you will get? The absolute value of x equals to what? 2. And x is less than 0. What is the x, the negative x, that its absolute value is 2? Is -2. So what is this? This is x. What is x? X is -2. So what? This is what? Now add them. -3. The answer is B. Okay. Excellent. Now, how to find the inverse? By the way, another way to solve this question is to find the inverse. Why no one of you thought about that? It's okay, by the way, don't use it. But another way is to find the inverse, then evaluate the inverse at 6, and you will get the same answer. But no need to do that. Now the question is how to find the inverse. To find the inverse, you need to follow these 3 easy steps. Step number 1. Replace f of x by y, solve the resulting equation for x in terms of y, then interchange x and y, and then replace y by the inverse. By the way, you can also interchange and then solve for y. You can do that. Let's apply it here. What we will do, we will replace f of x by y. This one, replace it by y. Now solve this for what? For x. Some of you, they prefer to interchange here and solve it for y. It's okay, the same. Solve it for x, you will add 2 for both sides. Then you will divide by 3. You solve it for x. Now you can what? Interchange. If you interchange, you will get y equals to x plus 2 over 2. Now replace y by the inverse. Okay. By the way, I can just, in this step here, I usually stop here. Here I just write f of inverse of x and replace this by x. And that's it. This is the inverse. Now, if you look here, we didn't talk about the domain and the range of the inverse and the function, because here it is all the real numbers. Let's take a, you can check, by the way, if your answer is right or not. How to check that you are right? By applying the inverse function property. Now, if you find the composition of f and its inverse from the left and from the right, you should get x at the end. Find the inverse of this function. Again, the same way, you will replace f of x by y. Then you will solve it for x. Multiply both sides by 2. Then add 3 for both sides. Then what? Take the 5th root of both sides, or raise both sides to the power of 1 over 5. Now interchange. Now you have the inverse. Okay, you can also verify that what you did is correct and the inverse that you obtained. It is not necessary, but it is, of course, better. Do you remember 3.6 rational functions when you have linear over linear? Here it is, how to find the inverse. To find the inverse, you will do the same. Y equals to, you need to solve it for X. Some of you, they did this when they trying to find the range. It is the same. So you will just do cross multiply, distribute the Y, combine the X, the terms with X, then take X common factor, divide by the coefficient of X. You did solve it for X. Notice, ya shabab, no X value here, no X. So we solved X for Y. Now the inverse, now you can interchange here. And if you interchange, you will get that the inverse is X plus 2 and X minus 2. Now, what is the domain of the function? You can decide from the beginning, ya shabab. What is the domain of the function? All the real numbers except 1. So here we have X does not equals to 1. What about the range? And the range is all the real numbers except? No. Yes, you are right. Except 2. Why? Do you remember 3.6, the horizontal asymptote? How to find the horizontal asymptote? What is the horizontal asymptote for this function?
2.
It is the leading coefficient over the leading coefficient because they have the same degree. So it is 2. In fact, here you have the range of the inverse, and here you have the domain of the inverse from the beginning. By the way, you can check, look at the end. What is the domain of the inverse? All the real numbers except 2. Now you can do that, ya shabab, in general. This is just for fun. It is not necessary. Look here what you have. Linear over. You can do following the same process that we did in the previous slide. You will end up with this. To find the inverse of this one, just you need to interchange. This will be negative D, and this will be negative A. And B and C will stay as they are. You can apply that by the same way. No need to memorize. I think it is not difficult for you to do that, but I just do it for you here too. It is better to know. Do you remember the graphing techniques? How to sketch the graphs with shifting, with reflecting, and so on? Please try to revise 2.6. Do we have time to do that? Let's just do x squared and x greater than 0 is 1 to 1. What is the inverse? Who can tell me what is its inverse? How to find it? What you will do, you will replace f of x by y. Can you know the domain, the range from now? What is the range of this function? Y is greater than or equals 0. Clearly from the graph or from x squared. X squared is always positive. Now you will take the square root of both sides. You will solve it for x. You will interchange. Then you will have the inverse. So this is now the inverse. The inverse of this function is square root of x and x greater than 0. If you sketch the graph of the inverse, look at it. Can you see a relationship between the graph of the function and the graph of the inverse? Just move your head. Just think about the x-axis to be the y-axis and the y-axis to be the x-axis. Because this is what we do. We interchange x and y when we find the inverse. And if you draw them together, this is the interesting fact that you have, that they are reflection of each other about the line y equals x. Because we interchange x and y when we do the finding the inverse. This is what we are doing. We will stop here and continue next class, inshallah. Thank you and see you tomorrow.